where we're looking at more polygons. In fact, we're looking at more quadrilaterals. And our one for today is rectangles. And of course, you probably feel like, hey, I know rectangles. I know about rectangles. The opposite sides are parallel, opposite sides are congruent, all the angles are 90, and those things are true. Those things are true. There are a few other things we'll look at. First, just to throw ourselves back into our memory banks, how do you find the length of a segment? This comes from the very beginning of the course, and one thing we did then was we used the distance formula, because you can use the distance formula. But the thing that we most often did was we used the Pythagorean theorem, because we said we can draw a right triangle here using horizontal and vertical segments. And then we can apply the Pythagorean theorem. And of course, you should already know that this is 5 just from the 3, 4, 5, because that's the most famous right triangle in the world. But if we want to play it out just for practice, one leg is 3, so that's 3 squared. The other leg is 4, so that's 4 squared. So you can see that c squared is equal to 25. So c is equal to 5. Just to do another one for the sake of practice. So we want to know the length of this segment. We create a right triangle using horizontal and vertical segments. The vertical segment is 1, 2, 3, 4, 5. The horizontal segment is 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. 12. So then the question is, what's the length of AB, or the hypotenuse of our right triangle? So I use Pythagorean theorem, where of course C is the hypotenuse. It's the longest side. That's what I'm looking for. Sometimes I actually know the hypotenuse in one of the legs. I'm looking for the other leg. So be careful. But one of the legs is 5, so that's 5 squared. The other leg is 12, so that's 12 squared. And so c squared is 169. And if we take the square root of both sides, c equals 13. C equals 13. All right. So here's a piece you didn't know, because I've already said, that opposite sides are congruent, opposite sides are parallel for a rectangle. That's how they work. In fact, a rectangle is a parallelogram. So that means opposite sides are congruent and opposite sides are parallel. But further, we know that the angles are all 90. But this tells us that the diagonals are congruent. Now remember, the diagonals also bisect each other, because that's what's true for all parallelograms, is the diagonals bisect each other, but they're not necessarily congruent. But in rectangles, they both bisect each other, as do all parallelograms, and they also are congruent to each other. So I've got this little note here that says, if the diagonals are congruent and they bisect each other, what can be said about the 4 segments that are created? And what can be said is, all the segments are congruent to each other. So with a little bit of work, we can probably prove that triangles 1 and 2 are congruent, and that triangles 3 and 4 are congruent, because we already know these things are congruent, and we know the vertical angles are congruent. And well, for that matter, we already got sides, but I'm ahead of myself a little bit. But that's you know so much, and that's the beauty of geometry, is that once you learn these relationships, you keep making these connections. It's very useful. A rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, and LN is 6.5 feet. That's this. Find KM. Okay. Well, this is a problem where they have given us information we don't need. We don't need this for this problem. It's okay to know, we just don't need it. What we do need to know is that since all four of these segments are congruent, then if this one's 6.5, so is this one, and so is this one, making KM 13 feet. They tell us something, but there's the 13. Quadrilateral EFGH is a rectangle. If GH is 6, I can't draw this morning, and FH is 15 feet, find GJ. Well, again, I find myself with a piece of information I don't need, because really what I am dealing with here is they tell me this whole diagonal here is 15, which means each piece is 7.5, because they bisect each other, which means each piece is 7.5, which is the measure of GJ, interest B. Quadrilateral RSTU is a rectangle. If the measure of angle RTU is 8x plus 4, so RTU is this angle right here, that's 8x plus 4. And the measure of SUR that's this angle here, is 3x minus 2. Find x. All right. So here we have algebra in our geometry problem. That's what we have. And when we have algebra in our geometry problem, we're usually trying to find two things that are equal or two things that add up to something. Now, just looking at this picture, I don't see a direct connection between the two marked angles. What I'm saying is they're not like alternate interiors, because we do have some parallel lines with transversals here. They're not in the same triangle, because you got four triangles that are created, really more than four, but four that are kind of staring you in the face. Triangles that are created by the diagonals. And so, it's not, just blatantly obvious. So I had to start looking. Well, I would note that these two segments are congruent, so these two angles are congruent. So not only is this 8x plus 4, but this is 8x plus 4. And perhaps at that point you see it, because this angle is 90, the whole thing. So our two algebraic expressions have to add to 90. So that would be 11x if you put the 3x and the 8x together, and plus 2 if you put the minus 2 and the plus 4 together. And they have to add up to 90. So 11x is 88. X is 8. X is 8. Pretty sure that's right. And that's what they asked me to find was the X. What if they'd asked me to find the measure of one of these angles? Like I put the 8 in here, I get 64 plus 4 is 68. So that's 68. That's 68. I put the 8 in here. That's 24 minus 2 is 22. What is 68 plus 22? It checks, doesn't it? It's 90. So you can see they got that equation that we did, and they get the 8 that we did. Quadrilateral EFGH is a rectangle. Okay, you can't just tell by looking. It's nice they told us. And then they say the measure of angle FGE is this. So FGE, that's this angle right here. And they tell us it is 6x minus 5. Then they do HFE, which is this angle right here. And they tell us it's 4x minus 5. Find x. Well, you probably at this point are like, well, yeah, these two angles are congruent, so that's 6x minus 5. And those two have to add up to 180. Add up to 90, rather, because it's a right angle. So you put the x's together, you get 10x. You put the minus 5 and the minus 5 together, right? The minus 5 and the minus 5, you get minus 10, and that's going to be 90. So 10x is 100 when you add the 10 to both sides. So x is 10. The answer is A. I'll leave you to go back and prove that. So earlier we saw that if you have a rectangle, the diagonals are congruent. Now we have the converse of that, which says if the diagonals are congruent, then then the parallelogram is a rectangle. So that gives us, we can take it and look at it either way. You can swap the if and the then. The hypothesis and conclusion. Some artists stretch their own canvas over wooden frames. This allows them to customize the size of the canvas. In order to ensure that the frame is rectangular, before stretching the canvas, an artist measures the sides and the diagonals of the frame. If AB is 12 and BC is 35, that's inches, and CD is 12, and DA is 35, okay, let me stop right there and say, right now we know this is a parallelogram because opposite sides are congruent. We know it's a parallelogram. We just don't know so you cut your sticks and you put them together and you for sure got a parallelogram, but are their angles 90? Is it a rectangle? And then they come along and they give us this. BD is 37, that's one diagonal, and AC is the other. And they say, explain how an artist can be sure that the frame is a rectangle. Well, because opposite sides are congruent and the diagonals are congruent, by the previous theorem, we can say that it's true. We don't have to do any work. That's proof. That's proof. Max is building a swimming pool in his backyard. He measures the length and width of the pool so that the opposite sides are parallel. you can see they marked all their parallel sides here. He also measures the diagonal of the pool to make sure they are congruent. How does he know that the measure of each corner is 90? So he does this diagonal thing, make sure they're congruent. So we look at these A, B, C, D choices. It'd be a good time to pause, look, think for yourself. Since opposite sides are congruent, or opposite sides are parallel, is that enough? No. Since opposite sides are congruent, is that enough to say it's a rectangle? No. Since the diagonals of the parallelogram, because you know it's a parallelogram because opposite sides are parallel. You know, he made sure of that, Max did. Is that enough? Yes. Answer C. It's a parallelogram with diagonals congruent, then it is a rectangle. I might have wished I hadn't done that. It says quadrilateral JKLM has vertices and it names them. It says determine whether JKLM is a rectangle using the distance formula. So here's our deal. This is that. Okay, here it is. I'm going to show you this one first because I got these questions. So here's my picture in nicer, cuter form. And what we want to prove is two things. Is it a parallelogram, which means you got to find out if the opposite sides are parallel. Or you can find out if opposite sides are congruent, do the same thing. But parallelogram, opposite sides are parallel. And then are the diagonals congruent? Because the first one proves that it's parallelogram. It doesn't prove that it's a rectangle. So we gotta do both. So the first thing I would do over here is I would make sure that this is rise 1, run 3, rise 1, run 3. Those are parallel. I'm going to erase it because I don't want all that in there. And I would rise 1, 2, rise 1, no. Rise 1, 2, 3, 4, 5, 6, run negative 2. Rise 1, 2, 3, 4, 5, 6, run negative 2. So, you know, I'm proving that opposite sides are parallel. That's what I was doing there. Okay, so that's that first piece. Is it a parallelogram? Yes, I've proven that it is a parallelogram. So the next question is, are the diagonals congruent? So let's go back to our picture. Diagonals congruent means they have the same length. So I'm going to find the length of this one. By creating a right triangle, which is what I was reviewing you at the beginning of the lesson. And so this is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4, 5. So JL is going to be Pythagorean theorem with two legs that are 5. So now I want to find this one. Not drawn very well. I want to find this one. And I've got that. Which appear to be 1, 1, 2, 3, 4, 5, 6, 7. you draw, sometimes you mess up your own drawing. I'll look at it again because it seems like I'm not looking at it right. But I think I was. Find this here. I've got 1 and 7. Well, let's just do that. We'll see what happens. So c squared is equal to 1 squared plus 7 squared. C squared is equal to 50. So c is equal to the square root of 50. Yeah, I believe I was right. After all, it just looked really, really wrong for a second there. So I had this one, and I had this right triangle drawn with legs that were 5 and 5. So when I do the Pythagorean theorem on that, one leg is 5, so this is 25. The other leg is 5, so 5 squared is 25. So c squared is equal to 50, and c is equal to the square root of 50. So the two diagonals are the square root of 50 in length, therefore they are congruent. That's what they got as well. They did use the distance formula, but they still got the same answer. So quadrilateral, blah, 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 determine whether, it says by using the distance formula. Well, we just did one, but not using the distance formula. So it'd be a good time for you to pause the video, practice this, and see for yourself if you can handle this. The answer is yes. So here they say, what are the lengths of the diagonals? So I'm going to graph. Trust me, that's those points, like -2, 1, and -1, 3, -2, 1, -1, 3. They're there. And so they want to know, the question is, what are the lengths of the diagonals? So rather than draw the sides, I'm just going to draw the diagonals so they don't clutter up my picture. And I could use the distance formula, or I could do what I'm doing here, and that is rise 1, 2, 3, 4. I shouldn't have said rise because it makes you think of the slope. So it's 5, isn't it? Because it's the 3, 4, 5 triangle. For the other one, the other diagonal, it's horizontal line. You can count it, 1, 2, 3, 4, 5. The answer is 5. This is given, is our last problem. Given parallelogram ABCD with C is 5, 4. Let me mark that. Find the coordinates of A if the diagonals AC and BD intersect at 2, 7. So 2, 7. Okay. So the diagonals bisect at 2, 7. So whatever this is, there is another one on the other end. In other words, this is the center, so we've got to go on up. So we went up. Let me see. This is 1, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And so this is A, because you got A, somewhere over here you got B, you got C, and somewhere here you got D. So the answer is -1, 10. There's a little more we could do with that, but we'll leave that for there.